So like I said, with area, you know, as long as I promise you, math literacy becomes so easy as long as you are able to create these equations for yourself as you go. Whether you're dealing with area, whether you're dealing with perimeter, surface area, cost calculations, you need to be able to think in that way when it comes to, you know, creating equations for yourself as you go that relates words, and you know you're creating these statements for yourself as you go, because it then makes it easy for you to answer whatever questions are given to you. Also, if you're given a rate, something per something, that's a rate, né? Write that rate as an equation, write that rate as a statement. It makes it easy for you to actually also answer questions that are given to you. Okay, so you can please do these questions on your own, where you are like, I've given you a question here. It's just a practice activity to see if you can calculate area. Okay, but I'm gonna ask us to please do this one because it's a bit of an irregular shape. I'm going to ask us to please calculate the area of the classroom. The other shapes, I think you should be able to calculate those areas. You should be able. Okay, let's do this one. Okay, let's please calculate the area of the playground. That's going to be our number one. Then we're just going to calculate the area of the classroom. Okay, area of the sand pit. Very easy. How would we calculate the area of that sand pit, Larato?
The area of,
The sand pit. The sand pit is the circle. How would we calculate the area of that sandpit?
okay, so we're calculating the radius, so it's gonna be radius, it's gonna be diameter over 2. And then after that, we're gonna use the pi equals to 3,142. And
Okay,
the answer that
let's
is,
let's quickly look at this. Ne? Let's look at the sandpit, ladies. Okay, uh, we see that there's a black dot there. What does that black dot on that circle mean?
It's the middle part, the
It's
radius.
the center. It's the center. The black dots, ne?
Oh,
Okay, if they give you a circle, then there's a dot there. Sometimes they do put a dot, sometimes they don't. This is the center. So the line from the center to the outer part, what is this line called? Ladies, this line. From the center to the outer part of our circle.
the radius.
It's called the radius. But if I had the line from the outer part of the circle going through the center, going to the outer, what do I call that blue line?
Diameter.
The diameter. So in the case of the sandpit, are we given the radius or are we given the diameter?
radius.
Radius.
It's the radius. So if I had to calculate the area of the sandpit, how would I calculate the area of the sandpit? Lerato.
It's gonna be a radius.
Mm-hmm.
It's gonna be 1,5 divided by 2.
What's the formula that we use to calculate area of a circle? Please
It's
remember,
the
ne?
it's the
Yeah. Please remember, I'm not
it's
going to
five.
give any formulas, ne? Because I want you guys to know these formulas off by heart. But in an exam situation, they will give you. But sometimes they won't. Let's start to, you know, you don't know the examiner. Sometimes these examiners, they don't give these things. So please, let's just train our minds to, you know, if things are not given, we're not panicking. We already know them off by heart. How do we calculate area of a circle? Okay, maybe let's do this activity. I think I'm too high. Let's see. Please go through the textbook for, okay, we're going to look at the following. Calculate the area and perimeter of. Okay, so we're just going to be looking at area for now. Can you please calculate the area of the following shapes? We're going to start with the playground as number one. Then we're going to do the sand pit as number two. Then we're going to do the, sorry, let's do the sand pit number two. Then we're going to do the classroom. It's going to be number three. Then we're going to do the vegetable garden as number four. Please, I'm going to add number five. Calculate. Please add this to number five and say calculate the space or the area covered by the grass. Let's say calculate the area covered. Sorry guys, I'm not using covered by the grass. Okay, so guys, this is a top view of like a school, right? The green part there, you see that green part, there's a light green. Okay, I'm gonna try to just show you guys what I'm talking about. This light green region, let me show you this one. Okay, this light green region, do you see this one? All of that there. Okay, that's the grass. Right. So how do you think we would actually go about calculating the area that is covered by the grass? Because I want to now determine, there's grass that is covering this whole entire school. There's grass that is covering, that is around the playground area, around the classrooms. Okay, remember, this is just the top view of the school. There's grass around the vegetable garden, there's grass around the sandpit. How would you think you would actually go about calculating the area of just the grass? We just want the area that is covered by the grass. What do you think we would do?
We're gonna use the 15 meters and the 20 meters.
Okay, good. Is that it?
So we're gonna calculate the area of the rectangle.
And then?
So after we do the then we're gonna calculate the playground, I guess the shape of inside the ground. I mean inside the square, the rectangle. We're gonna calculate the playground, classroom, vegetable garden, and the sandpit. Yeah.
And then you're done. So you've got all of these areas. You've got the area of that, the entire rectangle. You've calculated it. Then you would have the area of the playground, the area of the classroom, the area of the vegetable garden. Then what do we do with all of those areas, Smash? Do we add them together? What?
We subtract.
Yeah, we're gonna
Good. We're gonna subtract. Okay. So please, let's just quickly calculate these areas. I want us to please calculate the area of the playground. Faith is gonna do that one for us. Number 2, area of the sandpit, it will be Lerato. Number 3, area of the classroom. Please take note of that classroom. Okay, we've got 2 shapes in one. It will be Tiara. And then last one, we've got area of the vegetable garden. Please make sure that we convert all our units. Okay, I'm adding all of this. Convert all of the units to meters. Okay, the final answer should be in meters squared. Okay, please add that. Final answer should be in meters squared. So they'll say final answers in meters squared. Okay, let's quickly go through that, please. Let me not take these questions for granted. I'm seeing we're making some silly mistakes. Okay, let's quickly. 1, we want the area of 1, 2, 3, and 4. Quick, please just put up your hands once you're done so that we can get started. Ne? Please, it's very important that you do these activities so that we see what you don't understand, okay? Because I'm already picking up something. Okay, don't forget to put up your hands. I hope you can hear me. Okay, don't forget to put up your hands, please. Or just type done. Okay, we're going to follow that order. Faith number 1, Lerato number 2, Tiara number 3. Then whoever wants to do number 4 can do number 4. And whoever wants to do number 5 can do number 5 for us, okay? Quickly. Remember, when you're calculating area, we're just calculating the space covered by this playground. The space that is taken up by the classroom in the school. The space that is taken up by the vegetable garden. The space that is taken up by the sandpit. Okay, so that's basically what we are trying to find out. Okay, quickly. Right, are we done? First one. Okay, what shape is that? Are we done? First one, Faith, ready for action?
Yes.
Oh, okay, good.
I said.
Let me just set up my live here. Right. I'm going to just relabel this. I'm going to do the solutions in red. Okay, number 1. Yeah.
I said, the height 400 centimeters divided by 100. I got 4 meters.
Okay.
Ma'am?
Yes, I agree.
Yes. Then I said area of a triangle of the playground is half times base times height.
Is equal to half times base times height.
Yes.
Okay.
And then I said half times 6 meters times 4 meters. I got 12 meters squared.
12 meters squared. All right. Remember, ne? Good. Well done. So remember, when it comes to the triangle, ne? The tip that I also gave you guys last week, even if they give you a triangle and they also give you this is called the hypotenuse in this case. Maybe this was 7.21 meters, right? For you to get the base and the height, what did I say? They must make what? The base and the height? A T, right? So the base and the height, they must make a T. okay, then you can choose whichever one that you want to use. Whichever one can be the base. So if they're not making a T there, it's not the height and the base. Okay, so you can already see that with some of my other students, they think that, for example, if you're given the 7.21 meters, then they'll say that Abanye will say that the 400 meters is the base, and then the 7.21 meters is wrong. That is not making a T. Okay, all right. Obviously, it kind of looks like a T, but I think you get what I'm saying. It needs to look like this, right? It needs to be like a perpendicular height. Okay, so the base needs to be at 90 degrees to the height. Okay, I think that we learned in grade 9 perpendicular height. So the base and the height need to be at 90 degrees to each other, right? And then yeah. Okay, even though it's not denoted there, but that is actually a right angle triangle. Right, good. Let's look at number 2. How do you calculate the area of a circle there?
Okay, I'm gonna say area equals to pi times r squared.
Okay, for now we can use always for now, ne? In all the lessons, let's use my pi as 3,142 all the time. Okay, but they'll always tell you what you must use for your pi in an exam situation. Okay, so what must our pi be, Lerato?
3,142. So I divided 1,5 meter by 2 and I got 0,75.
Okay. Do we have to divide the 1,5 by 2? Let's think about that for 2 seconds. When we are dividing by 2, we are doing what?
Oh,
Anyone? Yeah, remember, to get the diameter, we said that it is equal to radius divided by, no, hold on. Let's say, for example, you are given the diameter. Okay, right? How would you get the radius? You say diameter divided by 2 will give us the radius. Okay, that's what we're doing. But here, in this case, what are we given here?
The radius.
It's the radius. And then what is this question asking? What are we substituting in this formula there? That R, what does that R mean?
Radius.
So do we have to then take the radius and divide it by 2? No. Okay, so I'm just going to substitute. Yeah, it's going to be 1,5 meters all squared. Okay, right. Let's get the answer.
7,065 meters squared.
0.065
meters squared.
0.65?
Yes.
Are we all getting that?
Miss Lee, is it not 0.695?
95, okay, meters squared. Okay, Lerato, Gavin?
Oh, I left the 2. Oh, now I see. On 3,40, I said 3,14. I forgot the 2.
Yeah, it's 3,142, ne? Yeah, be careful. Even if in an exam they tell you to use 3,142, you must use it 3,142 if they're telling you to use it like that. Otherwise, your answers will slightly be off. Okay, good. Are we happy with the area of a circle?
Yes.
Let's calculate area of the classroom. Tiara?
So first you have to convert the centimeters to meters. So the 150 centimeters is going to be 1,5 meters. And the 500 millimeters is going to be 5 meters.
How did you get to 5 meters? What did you do?
I divided by 1,000.
Good. 5 meters. And then anything else that we need to convert?
No, that's all.
Good. Calculate the areas, please.
So the area of the rectangle is going to be 5 times 9,5 because you add the 7 meters and the 1,5 and the 1 meter. And then that's going to be 47,5. And then...
Good. So you're saying to get the area of the rectangle, ne? What did you do? Tell us again what you did there.
You add the 7 meters.
So you took the 7 meters, correct? And
the 1,5.
Plus 1,5. So that gives us 8,5 then.
Plus the 1 meter.
Good. Plus the 1. So that gives us 9,5. Is that what you said?
Yeah.
Good. So you take that 9,5, which is the length, Okay, and then you do what with that as well? Then what?
And then you multiply it by the 5 meters.
Multiplied by, remember it's length, multiplied by the breadth. So you can see that our breadth is 5 meters. Well done. Okay.
And then that's 47.5
47.5 McDonald's
meters squared,
meters squared plus the area of the square. The area
which
of the
is
square is this part
1,5 times 1,5.
Good. 1,5 meters times 1,5 meters. Answer?
2,25 meters squared.
2,25 meters squared. Please double check your answers for me, guys, as well. Okay, answer, final answer.
49,75 meters squared.
49,75 meters squared. Well done. Okay, so very important when it comes to these irregular shapes, you need, if we're talking about area, okay, you need to now be able to split up, this section into two parts. We've got that first part there. We can see that it's the, part at the top, area 1, and then you can see that the part at the bottom, we can call that area 2. So we can see that area 2 is a rectangle, area 1 is a square. Then you just apply the formulas that we use to calculate area of a rectangle and a square, and it becomes easy stuff. Okay, cool. Who would like to calculate the area of a vegetable garden for us? What shape is that? And then what formula do we use?
It's a square shape. So we're gonna first convert the 200 centimeters into meters. So it's gonna be 200 divided by 100. And I got 2 meters squared.
2 meters, just 2 meters, because it's just length, not squared.
Yes. So area is equal to length times length. So it's gonna be 2 meters times 2 meters. The answer is 4 meters squared.
Well done. Okay, so we've calculated the area of all of these shapes. One last one. Remember, I added a question there, number 5. I said then, therefore, hence. Okay, maybe in the question they'll say, hence, calculate the area covered by the grass. Right? So, who gave us an approach? Konjo, what did we say we needed to do then? If I wanted to calculate the area that is taken up by this grass in the school, what must I do? Please remind me what we said.
We're gonna calculate the shape.
Okay, whoever's talking, yes, continue. Tara.
You're gonna subtract.
Faith.
You're gonna subtract all the numbers from area of playground to area of the circle.
Okay, what do you mean?
Like you're gonna take the process. Answers and then you minus all of them.
Okay, from what? I'm just gonna start minusing. I'm just gonna start taking the 12 meters squared minus 7 minus. Is that what you're saying?
Don't you start with the bigger number first?
Which is
49.
Okay, who agrees with what Faith is saying? Faith is saying we're gonna start with a big number, which is 49,75, and then she's saying we're just going to minus the others. Just take 7.0, minusing the 12, minus the 4. Do we agree with what Faith is saying?
I have a question. Are we not supposed to first calculate the shape, the 16 meter and the 17 meter?
Yeah, guys. Firstly, for us to, you are correct. For us to be able to calculate, the area that is covered by the grass, we first need to calculate what is the area of this entire yard. Okay, what is this area of this entire yard? I'm trying to indicate it with my drawings here, but it's becoming a bit messy. Okay, I want to calculate what is the area that is taken up. I'm going to show you by this entire yard first. Okay, then after calculating that area, Faith, then I will minus, because I'm going to minus this part because the grass is not there. Then I'm going to minus this area that I've calculated because the grass is not covering the classroom. Then I'm going to minus the sandpit because the grass is not there on that space that is taken up by the sandpit. Then I'm going to minus the vegetable garden because the grass is not there where the vegetable garden is. Does it make sense what I'm saying?
Yes.
All right, so how do you calculate the entire area of the yard?
We're going to say area equals to length times breadth.
Mm-hmm.
So it's gonna be
Mm-hmm.
15 times 20.
Mm-hmm. 15 meters. Please, ladies, units, ne? Times
Yeah.
20 meters. Please. Answer?
300 meters squared.
300 meters squared. Then
now we're gonna start minusing the area of the thing first.
good. So now we're calculating the area that is covered by the grass. So we're gonna take that 300 meters squared, then we're gonna minus what? Because remember, we're saying we minus the area of the playground. What was the area of the playground? It was the first one, 12 meters squared. Minus, ne? Okay. Minus the area of the second one was the sand pits, which was 7,0695 meters squared. Minus, okay, the area of the classroom, okay, which was 49,75 meters squared. Minus the area of the vegetable garden, 4 meters squared. So we're going to be minusing all of these. Okay, I'm going to write the total equal here. What's my answer?
It's 227,1805 meters square.
200 and you say 27,1805 meters squared. And then they'll just say, round off your answer to 2 decimal places for me, Larato. I mean, Tiara.
227,18 meters square.
That's it. Okay. Therefore, that is the area that is actually covered by the grass. Okay. So it's a very, very important concept when it comes to area. Please, a lot of students, I don't know, when it comes to this concept, they get it wrong. Okay. So it's very important that we understand it and we apply it. If the grass is not covering a particular space, you remove that space because it's not on, the grass is not, in the playground. Okay, so you minus that playground, you minus the classroom. Obviously the grass is not in the classroom, it's not covering the classroom space. You minus that, you minus. If you understand that, you should be fine with that. Okay, let's quickly look at this one here.
That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.